Hello everyone, welcome back to another video. Today we're going to have a look at what the antiderivative of functions of the form 1 over x or 1 over linear x. If you remember, like when we've sort of done derivatives in the past, when we've looked at, antiderivatives in the past, and we've said the antiderivative of x to the power n is equal to, we increase the power and then we divide by that power. And we do that, but we've said n not equal to -1. And why is that? It can't be -1 because if n was -1, then we would be dividing by 0 down here. And we can't divide by 0, that's undefined. So when it's 1 over x, when we've got that situation, when the power is -1, then we need to do something different. And what we do is the following. Hopefully your math teacher will teach you in class about where this antiderivative comes from. I'm just going to skip over that here. I'm not going to spend time on that today. But so if you've got 1 over x, the antiderivative of 1 over x, then it's beautiful. And you'll see it that the antiderivative is log e to the x, okay, plus c. Just a reminder about what log ex looks like as a graph. Remember, the graph looks like that. It sort of goes up and across. And so it's only defined for positive x. And that's why we get this here. That's only defined for x greater than 0. It cannot be equal to 0 and it cannot be less than 0. And so we always need to put that little provisor in there. If you also study specialist maths, you'll see that they'll tell you that the integral of 1 over x is actually equal to, and this defines all, is log e modulus of x. So that forces that mod x, that forces it to be positive. But it's harder to deal with all those circumstances. So in math methods, we just say, well, it's equal to log e x as long as x is greater than 0. In specialist maths, you need to do a little bit more to work with those functions. Similarly, if you've got a linear term down the bottom and it's only for linear, it can never be anything x squared, x cubed, it can't be sine x, cos x. This does not work for any of those. Only if it's a linear function down the bottom, then it's equal to, you probably can guess these by now, we've done so many, but 1 over a, you divide by whatever's in front of x, and then the log e of the function that we have plus c. Again, whatever is inside of that bracket needs to be greater than 0. We can't have log e of something that's negative or equal to 0 for that matter. So ax plus b must be greater than 0. We could also write that as x greater than negative b over a. So if you've ever got those situations, you can just say x greater than negative b over a, depending on what your b is and what your a is. Okay, well, I hope that makes sense. It's not a very long video today. We just want to have a look at a couple of examples and we'll be done. So let's just have a look at this. I might just leave that there so you can sort of see it as we go. So we want the integral of 3 over 7x dx. What I like to do always is just to get rid of the crap out from the integral. So if I just take 3/7 out the front, I'm just left with 1 over x dx, like so. And so then it's quite simple. 3 over 7, 1 over x. The antiderivative 1 over x is log e x plus c. There's a constant of integration. That's the final answer, but we just need to qualify that, say that x is greater than 0. Okay, and that is all we need to do. So nice and easy. Let's have a look at this one here. Again, I'm just going to take out that -3 out the front, because just the constants just make things messy, and just like them sitting out the front so we know that we don't have to deal with them. Okay, so just taking that -3 out the front, and we already know what the antiderivative of this is. That's the ax plus b situation. So it's 1 over a log e ax plus b. So it's going to be -3, and then it's going to be 1 over 5. So that 1/5 comes out the front, and then it's going to be log e 5x plus pi plus c. Okay, it's easy as that, but we just need to qualify when this function is allowed to be, if there's any sort of domain restriction on here. And the domain restriction is, I'll sort of tidy, I'll write it, but basically that 5x plus pi must be greater than 0, not equal to 0, greater than 0. And so let's just tidy this up. So -3 times 1/5, so that's -3 over 5 log e 5x plus pi plus c. And let's just tidy that up. We'll just say x is greater than negative pi on 5. So just solving that so that we get that final answer, moving the pi to the other side and then dividing by 5. And so that is our final answer there. And I hope that makes sense. That's all we're going to do today. That's how you antidifferentiate when you have something to the power of -1. See you in the next video.